My name is Damon Burgett from Stable Design.
I'm Alex Parlato, also from Standing Design.
And this is our uniform. We're going to talk about checking your vector tiles. The subtitle is Cartography-driven tile engineering. We're not talking about the engineering of tiles themselves, but really more about how to analyze statistics in vector tiles to create a great map. I'll push because, oh yeah, you're.
All right, so how many people pack t-shirts for the trip to State of the Map here? 4. Fewer than I thought. Okay. How many people pack a parka? Right. Why? Because you knew you were going to Virginia in the summertime, you checked the weather, and you knew what you were doing all day. So tile engineers have a similar problem. We don't always know what trips the cartographers are taking when they create tiles based on the data.
Yeah. So yeah, there you go. Sorry. It's a little awkward, this like slide changing. So I'm just gonna stand over here. Does that work for everyone? Cool. You can stand right here. I'll stand over here. We're not gonna try to fight each other. So recall back to our colleague Stephanie's talk on the yellow brick road of vector tile cartography, right? This is a simplified version. It's a lot easier on this one. You take the data, you make tiles, and then you stylize them, right? Well, cartographers are in a way the product designers for maps, right? So they know what we're trying to make for their given use case. So we are really looking at techniques that you can use to then take the data that's gleaned from cartography and go back and inform tile engineering. So let's talk a little bit about why this matters. Why do you even care if your vector tiles are small or big or what, right? Well, one reason is we all develop on fancy MacBook Pros or Airs with good internet connections, but a lot of your users are going to be in crappy Android phones and 3G bad quality connections. So squeezing the most out of that connection really matters. So if your vector tiles are much larger than they really are doing, you're going to be transferring a lot more data like as your user is using the map. To really understand what's happening when we're looking at vector tile sizes, we need to talk about the patterns that we see in tile sizes, in vector tile sizes. Does anyone want to take a guess about what city this is? New York. New York. Good, you got it. Perfect. Now, why can you tell it's New York? This is a map of tile sizes, by the way. You can see that the biggest tiles, this is the bright yellow tiles, are in areas that have the most like infrastructure and roads and et cetera. Guess what? Those tiles are also going to be the tiles that your users are loading the most for most use cases, of course. What city is this? I don't think anyone's going to guess this one. Paris, right? Again, a lot of the largest tiles, this is at higher zooms, are in these really dense areas. It gets even stronger as you go lower zoom that it covers the whole city. When we're thinking about tile size, well, the point I want to make with those is that when we're looking at tile sizes, we don't really care about things like the median tile size, the mean tile size. What we really care about is where are the big tiles and how big are they and how can we make them smaller? Because those are the ones that are impacting your users the most. Really abstracting away this.
You said big tile, what does that mean?
Well, it's all relative in size. We'll talk a little bit more about that. If you want to talk about a general size range, we usually use about 500 kilobytes as a good like level for like that's a target max tile size. Anything beyond that is gonna, you're using a map, you're gonna load a lot of data. But again, it depends on the use case and everything. So I didn't want to talk about specifics here. When we think about tile sizes, let's talk about why tiles are big and why we're always dealing with this challenge, right? So this is the axiomatic curve of tile density. So that for any given tile statistic, in let's say max tile size P95, the 90% of tile sizes, you tend to see this kind of pattern where you have tiles that are pretty small at low zooms, they get big in the middle at mid zooms, and they get small again at high zooms, right? Why is this? Well, if you look at sort of the coordinate precision and density of tiles across zoom levels, at zoom 0, most features are quantized into oblivion, right? So the tiles end up being small. In high zooms, you have enough coordinates where you could represent the full precision of the data. This is offset again by splitting the tile sizes. Each time you zoom in, you're cutting a tile in 4, and so tiles are getting less and less features per tile. You combine those things together and you get the axiomatic curve. We see this in real world data. This is Mapbox Streets over a bounding box of New York City, the same bounding box that I showed you earlier. You can see this in uses where zoom 8 is like you get the meat of the tile sizes here. This is an open map tile based schema. In this case, it's a little bit different. You can see there's this big peak at a middle zoom and you see it like increasing there. So when we're trying to solve for making tiles smaller, we're not trying to tag this real high zoom tiles or the real low zoom tiles. We're really trying to get those big tiles in the middle that are the ones that are cover enough area where they contain a lot of features, but are such that they're too large. You can see this, and this is the same tile set in like a viewer. You can see that like this tile size is mainly based on one layer, but you can, the whole pattern there is like this sort of encompasses this whole area of Manhattan. So that's why that tile is so big. It contains the road, it's trying to code the road network of Manhattan in one tile, right? Now, thinking back to cartography, right? As cartographers, we're trying to make a harmonious map. In some cases, in a lot of cases, that means that we're trying to make a map that as you zoom in any one location, you're not getting huge jumps in tile and visual density, right? You want the map to stay relatively consistent as you zoom in and zoom in. So we want to call this the platonic ideal of tile sizes. This is like the density that you might want to see on a map. Of course, it's idealized. So we take these two things, we take the axiomatic curve of tile sizes and the platonic ideal of tile sizes. There's all the stuff in the middle that we want to cut out, we want to remove, because that's all data that's being transferred over the network that we don't need to transfer. It's almost like cartography is sculpture. The tiles are this huge block of marble, and we want to get to Michelangelo's David here. So we're going to chip away what we don't need. Sorry, yeah.
Yeah, so with that analogy, right? Imagine if straight out of the quarry, you could get Michelangelo's David, right? Like you don't need to carve it down. So with tiles and knowing what styles we're working with, we kind of have that ability. So cartographers are creating style sheets, and going back to the first analogy, two analogies, track of it. But going back to our first analogy, the styles we're using as kind of that itinerary, and you know, whatever the weather is for the week or wherever you're packing, to make a packing list for what needs to go on those tiles, right? Because at the end of the day, if you have data in your tiles that's not rendering, it doesn't matter. It's not being used. So, cool. So yeah, we built a tool. We built a tool using Mapbox VT Shaver, which Mapbox uses to shade their tiles. And we have an internal API to run it. So essentially what this lets us do is it lets us lint your tiles against this tile, right? So we'll take a look at the data being served in your tiles and the data that's being rendered and be able to create some stats based on the differences between those two, right? And going back to some of those curves that Damon was showing, right? That's how we're trying to show what extra is in that kind of axiomatic curve between the top of that curve and that flat platonic idea. So what does that actually look like? Here's some of the output of this tooling, right? Just as an example, right? We can see a before size. That's the size of, say, this tile prior to shading it down and linting based on that style. The after size, right? So that's like the most that data could be reduced to still render that style the same way. And then we get some information about what extra layers, what extra properties are in those tiles, right? Like what actually is not being rendered, a little more detail.
Mm-hmm. And just one note too, when we talk about tile linting, what we're talking about is not simplification. It just is what is in your style, what is in your tiles that the style is not using, what features and what zoom levels, what layers, what properties. So the low hanging fruit, if you will, to really flatten that tile size curve.
Cool. So here we're looking at a real world example. And which map was this?
Yeah, this is from a internal experimentation we were doing with playing around with some different statement map styles. This, if you recall, was the Mapbox Streets tile size curve. Down below is the linted curve, right? So you can see effectively we're taking that big, large curve that we saw before, and you're seeing it being flattened just by the cartographer. And I think this is really interesting because there's a signal in the data of the cartographic process. You're seeing the cartographer aiming for this clear view across zooms, and you're getting it, and you're seeing it in the stats. Sorry, I'll let you do this one.
Yeah, no, so this one is OSM Americana. And we see a much more dramatic flattening. Lots going on here too. We have not done a further analysis to see what's going on at Zoom 2. But you can see, right, the style gives us really great information about how to get this flat curve and all that data that is just not being used that potentially could be shaved from these source files.
Yeah. And I think this big peak is something to do with admin boundaries or something similar. But if the peak were not there, this huge, crazy tall peak, you would see something similar with a spike at the end, right? Where you have the big center tile. And of course, it's going to vary depending on what bounding box that you're looking at. But again, we're looking at this area over New York City as an example. Yeah, this is just like a breakdown. And like we loaded in our little internal viewer to view our tile size. You can see this layer is place names is making up, 1.2 megabytes or whatever of this tile, like a lot of data here that's not being displayed at all in the OSM Americana style.
Cool. So what insights do we gain, right? We've kind of been talking about this and, in terms of just this kind of pure output. If we can go to the next slide really quick, right? So, first off, we can look at some of the basic information we get from this output, and we can take a look at the savings. And, if the savings we're seeing from this process aren't big enough to be enticing, we don't need to continue, right? But like, it gives us a signal to say like, okay, we should look a little further at these stats here, like why are things large? Then from there, oh, by the way, and to be clear, this is a real world scenario, right? These are from a route along in New York City. So you can take it for your specific use case, find out what specific tiles you might be serving, or you have a user journey or something like that you're trying to replicate, right? So these are numbers that we're getting based on the tiles you'd be serving, a real scenario. So going back to that JSON we showed before, right? It lets us look in there and say like, okay, we have these extra properties, or we have these extra layers, or maybe we can take some insights and understand that, we have a couple of properties that we're basically just using in combination to articulate one thing. Maybe that data can be defined, right? There's a lot of options here. So the thing is, this gives us information to either more straightforwardly cut out the excess data, right? I mean, that's what the linting tool gives us straight out of the box, or use that information to do kind of a more detailed curation of the tiles with the data that it's giving us. And you can also visualize in different ways, right? I mean, we're just showing numbers in the past couple of slides, but here, we have a violin plot showing the same thing. So at each zoom level, right, we're showing across the range of tiles, right? So let's go back to that route in NYC, and just, there's multiple tiles in each zoom. So this will give us a sense of like not only where how much data is served overall, but like, are there more tiles, like most tiles in Zoom 14 are actually in a decent data range, or size range, whatever. And as you go up, you are serving tiles that are huge, but fewer of them, right? So, you have different ways you might be able to visualize this to give the insight that you want.
So going back to the yellow brick road, I think one thing that our colleague also mentioned in the talk is sort of how we use open source tools to really pull together this full stack system of cartography. And one thing that we can do with this is basically hook this API up to our style repos. And when you commit changes, GitHub Actions can kick off a process that can do this linting, provide us reports, provide us the ability to get these insights. Because as we all know, there's sort of there in a lot of work that we're doing, the vector tile creation tile is maybe on a different team or a different silo than the cartographic side. So you not only need the technology to be able to lint tiles, you need to be able to make the case back to another team like, hey, you should spend your time on this. So that's what this API allows us to do, is to really say, let's look at the data, what kind of advantages are we going to get, and then we can make lists of like, we don't need these properties. We can remove this layer at this zoom. We don't need this layer altogether. It really provides us with the tools necessary to do this feedback loop and go back to the tiles and be able to really refine them. And to really see this whole system, not just this, but the whole system of a statement of vector tile cartography in action, you should check our colleagues' talk right here at 3:15. So with that, thank you very much.